All right, number 7, 8, and 9 all deal with simplifying radicals, and all have a little bit of different aspect to them that we need to talk about. So the first thing I would do with this is see if 162 is a perfect cube, so, or cubed root, I should say. So I would probably say, let me do math on the cubed root and take the cubed root of 162 just to make sure it isn't, and it's not. So then I need to worry about simplifying it. So again, I'm going to think about perfect cubes that go into 162. So 2 to the third is 8. Let's see if 162 is divisible by 8. 162 divided by 8? No, it's not divisible by 8. So then 3 to the third is 27. So let's try 27. 162 divided by 27. That does go in there evenly 6 times. So just start thinking of your perfect cubes and seeing if that number is divisible by a perfect cube. So once I know it's 27, I'm just going to break this up then into the cubed root of 27 and the cubed root of 6 I said was left. Because now I can simplify, the cubed root of 27 is 3, so it's 3 times the cubed root of 6. So that's just simplifying a radical. So whatever the root is, be thinking of those perfect cubes or squares, whatever it happens to be, and then just keep dividing that number divided by 8, that number divided by 27, until you find a perfect root that goes in there. Now 8 has a little bit of a twist to it, because we could start to try to figure out what perfect fourth. I can simplify these. If there were a plus sign there, I'd definitely do that. But this is multiplication. So really it's kind of like going backwards from this. Here we took this and broke it up into two things that multiply to give me 162. So now we're saying, okay, if I give you two things that are multiplied, I want to go backwards and say it's the fourth root of whatever that product is. So if I take 20 times 8, as long as I'm multiplying, I can do this. 20 times 8 is 160. So I'm going to put them together because I can't simplify the fourth root of 8 or the fourth root of 20 as is. But now when I multiply them together, I get the fourth root of 160. So now let's think of perfect fourths. So if you think about 2 raised to the fourth, 2 raised to the fourth power is 16. So 16 is a perfect fourth, and I can break this up into the fourth root of 16 and the fourth root of 10. So the fourth root of 16 I can simplify as 2, so it's 2 fourth root of 10. So as is, I could not simplify either of those individually, but now that I can multiply them, then I can break it up into two factors that do work. All right, now 9's a little different because 9 does have a minus sign. So now I can't put those together unless they're like terms. So if I had 3 square root 12s minus 1 square root 12s, I could do that. So when I look at this, I want to simplify. So when I think about 12, what perfect square can I break 12 up into? Well, I can break it up into the square root of 4 and the square root of 3. Minus, and the square root of 48, there's different perfect squares that go in there, but the biggest one would be the square root of 16 times the square root of 3. When you take 48 and divide it by 16, you get 3. So I can simplify the square root of 16. I can simplify the square root of 4. So I broke up the 12 into 4 times 3. 48 I broke up into 16 times 3. So now when I simplify, 3 times the square root of 4 is 2. So 3 times 2 is 6. So I have 6 radical 3's. Can't put those together because this is under square root and that's not. Minus, here I have square root of 16 is 4. I have 4 radical 3. So now when I add, now they're like terms, I can put them together. If I have 6 of those and I'm minus 4, I have 2 of those terms. So 2 radical 3. Okay, so that's simplifying. And again, for the test, I definitely look at number 8. Make sure that you know how to do a problem like that. All right, numbers 10 through 12 are all pretty similar. They're fractions, and they have 2 terms in the denominator. So to rationalize those denominators, to simplify, you have to multiply by the conjugate. So if I have radical 2 minus 7, I need to multiply by radical 2 plus 7. And remember, you're FOILing those out. You're distributing things because you're multiplying that whole term times whatever's in the numerator and denominator that I started with. So for 10, I would take 5 times square root of 2. This is underneath, or this is underneath the radical, this is not. So I have to leave it as 5 radical 2. Here I'm going to take 5 times 7, 35. In the denominator, I have to take square root of 2 times the square root of 2, square root of 4. The outer and inner product, because these are conjugates, will always go away. They will always cancel out because they're conjugates. And then the last term, negative 7 times 7, is negative 49. So we are foiling this, first, outer, inner, and last, but the inner and outer product will cancel. So now I just have to simplify this. Square root of 4 is 2. So I really have 5 square root 2 plus 35 over 2 minus 49 is negative 47. And that's my answer. So all of these, 11 and 12, will be very similar to that, so I'll go through these pretty quickly. This one I'm going to multiply by 6 minus square root 10 over itself, and again, we need to distribute those. So here I'm going to get 42 minus 7 square root 10. In the denominator, I'm going to get 6 times 6, 36. Inner and outer product will cancel, and I'll get a negative square root of 100. Square root of 100 is 10, so now I know I have 42 minus 7 square root 10 all over 36 minus 10 would be 26. And there is my answer to 11. And then 12, we multiply by 5 plus the square root of 2 over 5 plus the square root of 2. Now this one's a little bit different, so we need to talk about it. So when I distribute, again, now this is a square root. So I'm going to take the square root of 2 times 5. 5 square root 2. But when I take the square root of 2 times the square root of 2, again, I'm multiplying those, I'm going to get the square root of 4. So I also get something in the numerator that I can simplify. In the denominator, 5 times 5 is 25. The inner and outer product drop out, and I'm going to get minus the square root of 4. Now these do not cancel because there's a plus sign here that locks those two together, a minus sign here that locks them together with order of operations. So all I can do is simplify the square roots. Here I'm going to get 5 radical 2 plus square root of 4 is 2 over, here I'm going to take 25 minus 2. 25 minus 2, 23. And there is one similar to one of those three on the test where you have to rationalize the denominator.